I put this up. No, you know what? Leave it down. I'll come back to it. Any questions at all? Things clear? See how quizzes work? See how quizzes work? You see how everything? Okay. All right. Well, then I have one probability exercise for us to do. I think it's fairly straightforward. I think a cards needs to be placed, I think. So here's the deal. I brought deck of cards with me today. I figured rather than just let you leave, I figured I'd make you earn the right to leave. I knew it was a thing the entire time. I thought we'd have about 15, 20 minutes, and look at that. 15, 20 minutes worked out pretty well. So I got a poker deck of cards here, and I figured rather than just letting you out of here, I wanted to use the deck of cards to kind of stir the back part of our mind from 243 and remind me, tell me about a deck of cards. I like using these in class a lot because they're a really nice example of binomial distribution. So describe a poker deck of cards to me. Let me put the lights on too. Describe a poker deck of cards. How many cards in it? 52 cards. Okay, tell me about them. 4 suits. 13 ranks, good. 13 ranks, ace through king or 2 through ace, depending on how you count. 4 suits, diamonds, spades, hearts, clubs. Good. Tell me about the suits. How do we differentiate it besides the visual of the actual symbol?
Red and black.
Red and black. Ooh, there's a chair there. How much of the deck is red?
Half.
Good. That's why it's binomial. So if you reach in here and grab a card and pull a card out, what is the chance that the card is red?
50%.
50%. Good. Now suppose, Cassie, suppose you pull a card out of the deck and you look at it. And then I go to Rosie, pull a card out of the deck. And you still have that card in your hand. Let's suppose you pull the red card. With 50% likelihood, correct? What's Rosie's chance of pulling a red card now? If Cassie holds her card over here. So the probability, let's pull this up for a second. Go to the board. We'll go to the mathematics. Just trying to stir that back in your brain a little bit, get you thinking about it. So Cassie, what's the chance Cassie gets a red card? 50-50. Now, assuming that Cassie keeps that card in her hand and Rosie pulls, what's the chance that Rosie gets the red card?
25 out of 51.
Boom! Remember, there were 26 red cards in the deck. Cassie now holds one in her hand. Rosie's going to go in and grab one. If we want her to get a red card, as Michael said, there are only 25 left in the event space, and there are only 51 cards left in the sample space. Right. So this is 0.5, correct? What's this? It's 0.5-ish. It's 0.5-ish. It's close, right? Now, this argument will begin to fall short if we keep pulling cards in this manner, won't it?
Yeah.
If we pull another card out, another card, eventually you might get down to having 5 cards left, and you can't do this 0.5-ish. But you learned this back in 243. As long as you're sampling a small enough chunk of your population, you can assume that the samples are independent even if they're technically not, can't you? This is how Gallup polls work. Gallup polls work like this beautifully. They sample a person, they sample some other person, and they treat them as independent even if they might not be independent. You might actually get the exact same person twice. Or, once you've removed one from the population, removing one from, say, 1 billion doesn't change the overall percentage of what's left all that much. And that's why we use the binomial distribution in a lot of applications, for example, right now. And does this ring a bell? These words like population, proportion, with replacement, without replacement. Does this argument, is it 25 and 51 if Cassie puts her card back in?
No.
Then it becomes a half every time, right? So let's do it that way. Let's do it pure with replacement, pure replacement. And I figure we'll get you guys out of here as soon as Cassie pulls a red card. There you go.
Come on, Cassie.
Oh.
She pulled
Killing me.
3 of spades. Now we're not going to put that one out. Although, would you want it to be left out? If the rule was you get to leave as soon as you pull a red card. You want it left out, correct?
Yes.
Because although it's 25 and 51, of course the problem is if I take one of the unsuccessful ones out, it now becomes 26 and 51. And then using Michael's little proportion from earlier, that's right, the denominator stays the same, numerator goes up, fraction gets bigger. No! I'm going to keep it a half. I'm going to reshuffle, and I suck at shuffling. I shuffle like this. I can't shuffle the other way. My son can. He's 6. He's not even 6 yet. He's 6 and 3 in 2 weeks. Bastard can shuffle, he can spell ant. He can draw an ant better than his old man. You're not a bastard, Max. I love you, buddy. He's gonna see that in 12 years.
Never loved me, Dad.
All right, Nina, get a red card. We get out of here. What'd you get? We're working on a flush. That's not bad. What does a flush be? Flush is all the same suit, right?
Yeah.
And what does that beat?
Everything except for straight flush, right?
Straight flush it won't be, right? Does it beat a straight?
I don't think
It can't be a straight. No, it can't, just because there's more
Flush,
flushes
I
than
think
there are
flush
straights.
beats a straight.
But a straight flush would be definitely more rare. Four of a kind? No, I
No.
don't think it beats four of a kind. It's up there, though.
Yeah.
It's up there. Okay, but that doesn't change the fact that you guys can't leave yet. Rachel?
Okay.
Let's go. People are waiting. They want to get out of here. But they're not getting out of here with a queen. Sorry. They're not getting out of here with a queen. So what do we got? We got three of spades,
Pick 9.
nine of spades. Aha!
I want to see your card.
Aha! You can't because this is your population. Oh, sorry. We did damn party today. So what do we got? We got a three of spades. We've got a nine of spades. Yeah.
Yeah.
We got a queen of spades. We're gonna flush. This is great. Not a straight flush. I gotta keep the stop away from the collar. Just gonna take him out of my hair. There he goes. He grabs. He grabs the queen of clubs. We got at least two of a kind.
Got back in there.
Who's going? Who's gonna pull a red card on this damn deck? Who's gonna pull a red card on this deck for me?
I'll try
And you guess? Tell me your name again. Eric. Eric just made a claim, and I think it ties into what Rachel said earlier. Eric, you're gonna pull for us, and I want you, while you're pulling, to explain what you just said again. Or just say it again, what you just said.
Not only no one's gonna pull.
You don't think anybody's gonna pull a red card. Why do you think that, friend?
Well, until they're all black.
He say they're all black. Why would he say that they're all black? I love that, Eric. Thank you.
Because random is never.
We should have drawn one by now. Danielle? We should have drawn one by now. Cassie?
Yeah.
Yeah, I heard randomness. Clusters.
It's clusters.
I love this too. I love this too. Actually, can I, real quick, I'm glad you said that. I wasn't thinking of going there with this, but that's beautiful. What you just said. Randomness clusters, as I bashed over your guys' heads in 243 so often. So I want to 105. Oh my God, Chris, you poor soul. You got it 105 and 243. Let's come back to that. I want to treat the cards as a coin momentarily. I'm going to have to go in here real quick. Thank you for saying that, Cassie. I want to come back to what Danielle and Eric said, because what you guys said is definitely tied to this, but in a slightly different way. Not in an ordered way, but in an unordered way. Starter coins. Could one of you guys, is that Alex? Would you mind killing the one light back there? Thanks, friend. Okay, so here, what this is you guys don't remember this from 243. It's a randomizer that flips coins, heads and tails. So it's generating a 1 or a 0. If it's a 1, it's a head. If it's a 0, it's a tails. And every time I press F9, which is what Mimi was loathing from Mac, every time I press F9, it generates new heads and tails. Now here's my complaint. You guys are complaining that essentially you got 5 tails. I wanted a head. If you can pull heads out of this deck, then you can leave. And I'm a bastard because you guys pulled 5 tails. Well, guys, it's five tails right there. 5 tails right there. 5 tails right there. There's 5 tails right there. So I guess my point is, what's your point? No. You've got a very, very good point, Eric. You've got a very, very good point. Cassie, I love the clustering idea. Why is my counter-argument invalid with respect to the clustering?
You're only dealing with 2 things, apples right
Well,
there, 26.
Sure, but it's still proportionally the same. It's still half and half. Thank you, Danielle. That was very nice.
Sample size is much bigger.
Yes, Kaylee.
Kaylee.
That's the key. This is 200 flips of a coin, and I'm selectively going in and going, oh look, there's 5 right there. Well, but it's 5. If it's 8, there's 5 in there, right? Agree with me. Here's what I should be looking at, friends. The first 5, because that's what you guys did. I didn't say do it 200 times. I said do it for a while until you got pissed. And Rachel, you got pissed after 3. You said it's fixed. I believe that was her words. So let's watch that, friends. Oh, there's 5 heads. That's interesting. But look at this. How often in that first 5 spots, are we getting?
That's a black deck of cards, isn't it?
Is
There's no
it?
red cards.
What is it? This is Eric's claim. We're going back to full circle. Let me ask you a question. Draw again. Very good. Is there a possibility that this deck is fair?
There's a possibility that
What is that possibility that this deck is fair? Give me a percentage. Assuming this deck is fair, that is in my pocket, that you will never see because it's your population. What is the chance? Not because I'm a bastard, because it's your population. What is the chance of seeing the results you just did? Think about that. While you think about that, I'm going to load up a spreadsheet on. What is the chance of seeing the results we just got together? Is it here? Yep. That's good. I like that. While you're thinking about it, whoops, I turned circular reasoning on. Hang on. Formula. Yes. That's 1. All right. While you're thinking of that, I need to speak more. Because as much as I love Excel, I haven't learned DVA yet.
I mean, you were those little birds.
Little.
a little while. Keep coming down.
He's having to go really fast. I like top of the ski is what I like. So friends, what I'm doing right here is I've created. What is this called right here? What is this little T table thing called from 243? Go ahead, be brave.
I totally forgot.
Good, a frequency table. I love that. Or a distribution table. I like them all. It all says the same. It's a way of systematically keeping track of data. So what I've done is I said, okay, you guys pulled 5 cards, right? And we got 3 of clubs, 3 of spades, 9 of spades, queen of clubs, queen of spades, and I believe the queen of spades again. What got pulled last? I forget. It doesn't matter. It was a black card, right? So what this keeps track of right here is the number of red cards that were pulled out of 5. So I've made it binomial. If you pull 5 cards, you're either going to get 0 out of 5, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, or all out of 5 red. That's what you're going to see as a result. Fair with me so far? So far? Good. What this is doing very quickly is it's keeping track of trial after trial. Every time I press F9, I generate, you might recognize this command, ran between 1, 2. It's the exact same command I used on the coin flip, except instead of going heads, tails, I went red, black. But going back to what Danielle said, isn't that the same? Right? Whether it's heads or tails or red or black, assuming the card's going back in the deck each time, it's the same. Right? So, what it's doing is it's counting how many red cards there are. In this case, there's 2. In this case, there's 3. In that case, there's 2. In that case, there's 1, and so forth and so on. It doesn't care where they are as long as they're there somewhere. Good so far? Believable? Fair-ish? Fair-ish. Good. And then down here, it's keeping track of which one. So right now, it's putting the 1 in the 3 column because we have 3. Now it's putting 1 in the 4 column. Now it's 1 in the 3 column, 1 in the 1 column, and so forth. And then this column is keeping track of that cumulative. And this is a graph of it. So let me ask you a question, friends. Based on our beautiful little data right here, based on this beautiful data, assuming this deck is fair, what is the chance of seeing what we just saw?
Well, wouldn't it be 54 out of 1,500?
Oh, we actually saw this, Kaylee. Thank you very much. This was 0, but can we come back to that because it was beautiful. I'm gonna come back to that.
Okay.
Yes, it's this out of that, isn't it? Now watch this. Let's just add that to the. Let's add that to here. Let's do equals. Thank you, Kelly. That divided by that. Okay, and that's white, but I'm glad you can actually read it. There you go. There we go. Let's make it. Let's go ahead and notice it's changing a little bit. It's changing because the data is updating continually, and you're going to see it. You're going to see it pop around quite a bit right here. 50, 45, it's jumping around, so this guy's changing a little bit. This guy's changing a lot more. So going back to Mike's analysis of fractions, you can see why it's predominantly going down, because this guy's going up, one by one, and this guy is going up occasionally, but nowhere near as often. So this is predominantly shrinking, but it's hovering right around 2.9 or 3%, isn't it? 3% chance. Could we have gotten 3% without going through this whole song and dance? How could we have gotten 3% without going through this whole song and dance? What is the chance? I'm going to pause this for a second. We'll come back to it. What is the chance of drawing 5 black cards in a row? Well, what's the chance of the first one coming out black? Just Cassie. Cassie pulls the card first. What's the chance of her getting a black card? 50-50, 1/2, right? What's the chance of Rosie getting a black card? Because we put Cassie's card back, right?
Oh, okay.
We did. So what's the chance of Rosie getting a black card? What's the chance of, was it Rachel? You were next. What's the chance of you getting a black card next? Chris, what's the chance of you getting a black card after that? Eric, what's the chance of you getting a black card?
1, 2.
What do you do with all those fractions? You multiply them, Dina, because the chance of getting a black card first and second and third and fourth and you multiply. Oh, not there. 1 in 32, which is ish 3%, isn't it? That's ish 3%. Hot damn! Let's go back to the spreadsheet. Oh! Coincidence? I think not. It can't be coincidence. What's happening is, does this curve look familiar?
Yeah.
Yeah. Cassie. Yeah, damn it looks familiar. It's a binomial curve. It's a binomial. This is the Now, Kaylee, the reason why I said it doesn't matter when you said we gotta take that number and divide it by that number, notice how close those numbers are. The chance of getting all red and all black is the same. It's the same. It's how you defined red and black. So you got some symmetry. These should be the same. Those should be the same. 666. And those should be the same there. So what you've got is an empirical demonstration of the likelihood of seeing what we just saw. So here's the question, friends. This deck, assuming it's fair, what was the chance of seeing what we saw? About 3%. Should that have happened? There's the key. There's the key. There was a magical number. Giving you a pretty good sized hint right now. We're going to do it with my right hand. There was a magical percentage you looked for in 243. That was a cutoff for unusuality. You remember what it was? Look at my right hand if you need a hint. Anything that came in below 5% was deemed an unusual event, an outlier that shouldn't have happened. Well, guess what we just saw?
An outlier.
We just saw an outlier, which means, yeah, there's a chance this deck is fair. Now, you guys are all saying it's fixed, right? Chris, you said it was fixed. Rachel, you said it was fixed after 3. You were good at 12.5%. The hell with it! But the rest of us took a couple more trials, and we said, okay, now we're down to 3%. Now I think something's up. I think this deck is rigged. Now, Eric, you made a very strong claim. You said the deck is all black. A more safe claim would be what?
Oh, I was exaggerating.
I know, it's okay. It's okay. I hear the same thing every term. What would be a safer claim?
Over half is black.
Good. Maybe we've got too many black cards in the deck. That includes your claim, but also includes maybe there might be some red cards in there we just didn't get them. But do we have a pretty good feeling that this deck has too few red cards in it?
Yes.
Boom. That's your first inferential exercise. You have no way of knowing because I'm not going to show it to you. You got your 5-card sample, didn't you? That's all you had. But the mathematics shows you that most likely this deck is rigged. Because the chance of it being fair is but 3%. And that shouldn't happen. Cool? That's just the 244. So we'll see you in 10 weeks for the final. Guys, we'll catch you on Thursday. We'll start putting some of this stuff in more of a context. Thanks for playing along. And y'all got a red card to you.